Welcome. I'm your tutor, Black Adam. We're doing chemistry. So this is a homework of the previous activity. All right. So we have a balloon there cooled, and then that is homework. Balloon cooled, and we have the balloon there, which is having the energy of 0.655, and then we also have work done, 382 joules. So we're going to look at the value that we have. We'll first start with the equation, and then after the equation we're going to look at the quantities that we have. So what quantities we have? We told that it cooled, so that means it released. So it also said releasing. So that means that energy should be considered as negative. So it's more like considering those quantities as vectors. And now that is 0.655 negative because it's released. So let us look at the work done on the balloon. So the balloon is our system. So that means that the work done on the system by the surrounding, and that is 382 joules. You can also look at the units and all the same, kilojoules and joules. So we will have to convert one of them. So we start again with our equation, looking at what we have to substitute, the values that we are given. So that's 0.655 kilojoules. Okay, that's kJ. And we got our value there, which is plus 382 joules. Okay, so once again you can see that the units are not the same. We know that 1 kilojoules, it's kilo means 1,000, so that's gonna be 100 joules. So converting joules to kilojoules, small unit to a bigger unit, we divide. So that is divide that by 1,000 and the unit becomes kilojoules. So units are now the same, then we can do our addition or subtraction. And that's how it is. So let us go there and find out 382. We divide that by 1,000. We get 0.38. Okay, so minus that gives us the value, which is in this case it's going to be negative 0.273. Units again, kilojoules. And we're not done, because remember from our problem we need to determine whether it is endothermic or exothermic. Once again we rely on the value of Q. So we look at the value of Q, which is the energy that is in the system or out of the system. Okay, so in this case that our value was negative because it cooled down, it lost. Anything that cools loses heat, so it cools because it loses heat, and then that means that in this case, because it's negative, it's exothermic, meaning that it released heat to the surrounding. And that's it. So we're done with A. So I broke up the problem there on top and separate segments so that we can solve them entirely, completely, without disturbance. And now we're given that gold heated from 25 degrees to 50 degrees, and then the volume is constant. Okay, so volume constant, what it means, so we'll have to apply that. Once again, we need to go to our equation. So equation is that internal energy is equivalent to the heat in or out of the system plus the work done by the system or on the system. So let's look again the heat there from 25 degrees to 50 degrees, and then we have our heat there given as 322 J, which is joules, the unit for energy. And then once again absorbs, so which is, remember that it gained heat, like when you it gains temperature, like when you absorb energy, temperature goes up, so that means it's a plus. and then we're gonna look at changing volume is 0 because the volume is constant as above, and then we are left with only the internal energy that it absorbed, which is 322 joules. Or else you can divide that by 1000 to give you 0.322 kilojoules. So either way is still fine, because we never had complications of different units and so forth. So right now we still need to find out whether it's endothermic or exothermic, and you can guess by the the sign of the Q there given. Because it is positive, it gained, so gaining is relevant to a positive sign. So that is gained heat from the surrounding, then that's endothermic. All right, so now we have the third problem, whereby we supposed to check if the energy gained or the energy lost is relevant in this case. So what will actually happen in this case will be insulated. What does that mean? It means that Q is going to be 0. Energy cannot leave, or energy cannot come in the system. So in that case, they're insulated. We only left with the other option there, which is surrounding do. All right, 1.44 kilojoules of work, and then we left with Q as 0. Only have W, work done on the system, and that means that from there we have to check for the values, and then Q is 0, and then the W, work done on the system. Do work on the system by compressing the gas, and then that means that is 1.44 kilojoules. So that is it. And now we have a little problematic situation in this case. Okay, that is 1.44 kilojoules. Our situation is, because we have no value for Q, is the process endothermic or exothermic? So that's a very big question. So Q there is 0. So what does that mean? That means that it's not positive or negative. 0 has no sign. So that means, because we rely on sign to determine endothermic and exothermic, since there's no sign, it means that it's not endothermic, meaning that it's not releasing heat, it's not consuming heat, and it's also not exothermic, it's not releasing heat. But that makes sense, because if you look at the problem there, it says insulated. So insulation means that heat can come in or out. And what system is that? That's isolated system. It's not a closed system. We have open system where energy can leave, matter can leave. We have so thank you very much for that. So we have open system, matter and energy can leave. We have closed system. So don't forget to subscribe for more. So it's closed system, open system, and isolated system. So we do more of that, and then I think next time when you have problems like that, so go through, like if you haven't watched the other video, you can go through the previous video and do the other problems. So these are the equations there. So you must know the meaning of work, electrostatic force, so internal energy, the volume, pressure, work, and we